We humans, we have incredibly sophisticated kinds of medical care. Other animals, not so much. Like, researchers have seen evidence that some sick animals will self-medicate by eating clay or certain plants. But there is one creature in the animal kingdom who takes the practice of medicine, air quotes, medicine, to a whole different level. And that, my friends, is the tiny ant.
Which really should not surprise us, right? I mean, ants are amazing. I mean, some ants farm. They farm fungi for their food. They herd aphids. I mean, if they've got agriculture, why not medicine?
That is NPR's #1 ant enthusiast and science correspondent, Nell Greenfieldboyce.
Hey there.
Nell, we wanted to have you on the show because you recently reported on one aspect of ant medical care that is truly mind-blowing, at least for me, even if you're not surprised about it.
That's right. I was kind of surprised about this, actually, despite my admiration for ants' many abilities. So there's this new research out showing that ants will treat certain injuries with therapeutic amputation.
Amputation. Just for comparison, how long have humans used amputation as a medical treatment?
So if you look at evidence like in the archaeological record, you can find ancient human skeletons with clear amputations that go back like over 30,000 years. So a long time. But the ants have probably been doing it for longer, much longer than us. And these aren't like super rare ants or anything. These are like common carpenter ants you can find in people's backyards in places like Florida.
So in someone's backyard right now, a tiny ant surgeon is effectively practicing Civil War-era medicine, aka amputation.
Yeah. And I mean, the Civil War medicine thing is a pretty good analogy because ants engage in battles and warfare.
Oh.
I mean, they hunt, they defend their territory. And that means when ants come home back to the nest, they can be injured. And it turns out their nestmates take care of their wounded warriors. I mean, lab experiments show that their medical efforts, including, now we know, amputations, are very often life-saving. And it turns out the ants are selective about when they perform amputations. They're not just like hacking off injured legs willy-nilly.
All right, well, today on the show, we dive into the anthill to check out their healthcare system. How scientists discovered that ants will perform medical acts that include clinical amputations, and how the ants determine whether or not an injured limb has got to go. You're listening to Shortwave, the science podcast from NPR.
All that sitting and swiping, your body is adapting to your technology. Learn how and what you can do about it.
I really felt like the cloud in my brain kind of dissipated. Once I started realizing what a difference these little breaks were making, there's no turning back for me.
Take NPR's Body Electric Challenge. Listen to the series wherever you get your podcasts. On the TED Radio Hour, over the last few years, former White House chef Sam Kass has been hosting meals that he calls Last Suppers. On the menu, ingredients that are at risk because of climate change.
My hope is not that people feel guilty or depressed. My hope is that we understand what's at stake is really like fully our way of life.
The future of food. That's on the TED Radio Hour from NPR.
NPR Plus is a new way to support public media and get more from your favorite NPR podcasts like Fresh Air.
Sometimes I'll actually preface the question with, if it makes you too uncomfortable to talk about, if it's too personal, just tell me. Here's the question.
For behind-the-scenes content, bonus episodes, and more, sign up at plus.npr.org.
Okay, Nell, so how did scientists learn that ants will sometimes treat an injury with amputation?
So the lead researcher who did this work is named Eric Frank, and he's now at the University of Würzburg in Germany. And he's really a tropical biologist. So years ago, he was studying some ants in Africa that will hunt and eat termites. And I talked to him back then, and he told me that ant scouts would go out and find a termite nest, and then hundreds of ants would march out together like an army in formation.
Like 3 ants next to each other in a 2-meter-long column. It's very peculiar, and it looks like a long snake walking on the ground.
So when the ants get to the termites, they would fight. There's like this huge battle. And when it was over, he would see the ants start picking up dead termites to carry home for food. But then he noticed that some of the ants that were marching home weren't carrying termites. They were carrying other ants, wounded ants.
So they were carrying their fallen comrades home?
Yeah, basically, just like soldiers,
Yeah, instead of no man left behind, no ant left behind.
Exactly. And so he was really surprised by this, and he did a study where he marked the injured ants to see what happened to them. And it turns out in nearly every case, the injured ants that were carried home made a full recovery.
We saw them again participating in hunts the next day.
What a rebound.
Yeah, so he got interested in how they recovered. And by studying this, he learned that ants will lick and groom a buddy's wound in the hours after the injury. And without this treatment, the injured ants would usually die. So it turns out this particular species of ant has a special gland that's full of antimicrobial secretions. And worker ants basically apply these secretions to the open wounds of their nestmates. It's basically like giving their injuries antibiotics.
But are these the ants that engage in medical amputation?
No. Okay, so that's something Eric Frank only observed more recently. And when I talked to him, he told me it was because of the pandemic, because he couldn't travel. So he started studying this other ant. The common name is the Florida carpenter ant.
I feel like so many scientists had to make do during the pandemic, People learned cool stuff just by studying what was around, which in his case was the Florida carpenter ant.
It's true. I wish somebody would put like a compilation of like pandemic desperation science where like scientists looked around and saw what was there. Anyway, so he's now looking at this other ant, and he knew that this species did not have that special gland that he'd been studying before.
So I just very naively wondered, well, how would they act if they get confronted with injuries?
So these are, injuries that they did experimentally in a controlled way in the lab, right? And pretty much right away, he and his colleagues saw ants amputating their buddies' injured legs.
This has been my big question this whole time. When you say amputating, how does that work? Ants don't have tiny little bone saws and surgical tools.
No, they don't. Okay, so here's what happens. An injured ant, an ant with an injury in like the upper part of its leg, will present that leg to a nestmate. And this nestmate will lick at the wound with their little mouth parts, like sort of move up to the shoulder area and like up at the joint, like start chewing through the leg to sever it. And this takes a while, like many minutes.
And you can see the other one not moving, not really flinching, and accepting it. And once the leg is removed and it falls off, the other one will come back and lick the little stump that's left, and it will still be presenting it. So it's clearly collaborating and wants the same thing as the one that is treating it.
So either the injured ants are just stoic or they don't feel pain or what, but they're clearly working together to make this thing happen.
The depth of ants, I just didn't realize any of this. And you said earlier that this procedure, for lack of a better term, is life-saving. How do researchers know that?
So they found that ants with similar injuries that were kept away from their nestmates, they didn't get amputations, those ants frequently died. So, no amputation, high chance of dying. And their studies show that's because without amputation, an infection from an open leg wound can travel to the rest of the ant's body and kill it. And Eric Frank told me to see if it was really amputation that was the key thing, he figured he'd just try his hand at performing ant surgery.
Since I observed these amputations, I was like, well, I'm pretty sure I can artificially conduct the same kind of amputations.
And so even when it was done by a human, the amputation treatment was just as effective in helping injured ants recover.
Really confirming that these amputations were saving the lives of the infected individuals.
Pretty cool, right?
So cool. But wasn't there supposed to be some clinical judgment involved here? You alluded to earlier that ants aren't just whipping off legs right and left. They are making decisions about what to amputate.
Well, decisions, that's a debatable word. But yeah, there is a part of this that the researchers found perplexing for a while. They had been studying ants with injuries to the upper leg and witnessing amputations at the shoulder. And so after they'd done this for a while, they were like, okay, what if an ant had an injury farther down, like towards its little like ant foot?
Okay.
So it turns out that for injuries lower down, like what would be the human shin, the ants did not amputate legs at all. So amputation was only occurring when the injury was high up in like what would be a human thigh. It was like, what? It doesn't make sense. And it took Eric Frank and his colleagues like a year of lab work to figure out what was going on. And basically, the important thing is that the body of an ant is just not like the human body.
How so?
Well, they don't have hearts like we do, for one thing.
Oh.
There are these muscular pumps distributed throughout the ant's body, including in its legs, especially in the thigh, the upper leg area. So it's weird, but like what it means is that if an ant gets injured in that upper leg area, the muscles are damaged, and so the pumping of liquid doesn't happen as quickly. And that means infection actually spreads slowly, more slowly than it would if the injury was lower down on the leg. And so basically what it means is that amputation really only has a shot at blocking the infection for upper leg injuries, even though it doesn't seem like it should be that way, but that's how it is for ants.
Right. And then if the infection is lower down on the leg, the infection kind of spreads fast, the amputation can't work, and it's deemed a little bit of a lost cause.
Yeah, so the researchers tested all of this experimentally in the lab, and they showed, experimentally that amputation is not effective for lower leg injuries. And so that's why the ants don't do it.
They are like doctors. They're like surgeons.
So for those injuries, they just spend a lot of time tending to the wounds, licking them, and whatever they do is often life-saving.
It's amazing to me that this treatment is so targeted to a specific kind of injury. They are making what we would call a clinical evaluation.
Yeah, but, they're not exactly like doctors. Like, it's not like they're sitting there thinking about it and weighing the pros and cons. I talked about this with some other ant experts who weren't involved in this study, like Daniel Kronauer. He's at Rockefeller University. And he told me, remember, this is evolution working, not like individual ants with like medical degrees and medical knowledge.
They have basically evolved over like thousands and thousands and probably millions of years to be kind of programmed, in quotation marks, to react to different kind of injuries in a certain way.
It's all to help the colony as a whole survive. And he told me, besides these antimicrobial secretions and amputations, ants sometimes do other things that seem a lot like human public health measures. So, for example, there's studies showing that if ants in a nest have certain contagious infections, the social networks of the nest will sort of get reconfigured. There's less connections, like everything becomes much more modular.
So they'll quarantine, essentially.
Yeah.
You basically socially isolate individuals that carry an infection. That's, of course, reminds you of the COVID pandemic maybe and what we were supposed to be doing.
And then there's other studies showing that ants with an infectious disease might just wander off from the colony and like go die somewhere else.
Oh, that's very self-sacrificing of that ant. And again, the amputation and antibiotic parts, it all sounds very caring.
Yeah, but like it's not like it's love. It's not like empathy or anything. It's just that like saving ant lives means that the colony has bigger armies and more success, just generally speaking, right? That's like one more soldier for your cause.
Right. Okay. I'm hearing you. This is evolution at work. These are adaptive strategies for the good of the colony, self-isolation, amputation, wound licking. It's all very cool. And I guess what's striking to me is given how useful it is, how have we not noticed this before? I mean, we've been living alongside carpenter ants for a long time.
Yeah, I'm sure people listening to this have seen these ants before, right?
Yeah.
I mean, they're not like the little black ants that invade your picnics, but the Florida carpenter ant is, this brownish ant, like a centimeter across. It's like in lots of places where people live. And, that is the part that really struck this other guy I talked to, an ant expert called Clint Pennick. He's at Auburn University.
This is an ant that I grew up with in my backyard. And so it's really interesting to see such a sophisticated behavior, that's literally happening in people's backyards from a common carpenter ant.
It makes me wonder, like, what else the ants are doing.
Insects in general feel like the final frontier to me. There's so much we don't know about what they do. And I hope when you find something else, you come on the show and talk about it, Nell.
Absolutely. I mean, I do admire your seemingly endless desire to hear this stuff. And, if I know ants, like pretty soon we're going to be hearing about something else. There's going to be another supposedly unique to human activity that it turns out, oh yeah, ants have been doing for millions of years.
Yeah, I mean, what would be really weird is if they had their own science podcast.
I mean, it would be serious competition for you, I got to say, because I would listen to that all day long. All day long, Emily.
I would love to co-host with an ant.